Antiderivatives. In calculus, you become very good at taking the derivatives of certain functions. So if I was to take the derivatives of these questions below, x squared minus 1, then the next one, x squared plus 5, and c, x squared, they'd all have the derivative of 2x. But what we want to do in this lesson is we're going to explore how to go in the reverse from given the derivative, what was the initial question? And that's called the antiderivative. So the question will be worded, find the antiderivative of 2x. And so in order to find this, you add 1 to the exponent, then you divide by the coefficient of the new exponent. So 2x would become 2x. It has the exponent 1, so you add 1. So since the new exponent is 2, you divide by 2. Simplifying that, 2 over 2x squared. So the general form for the derivative of 2x is x squared plus c. So you have to add that constant at the end because the derivative of any constant is 0. And you can always check your work in this lesson because the derivative of x squared, we know it to be 2x. So in this question here, I'm asking you to find the antiderivative of x squared. So what I need to do is I need to add 1 to the exponent and divide by the coefficient of the new exponent. So if I add 1 to the exponent, 2 plus 1 makes the exponent 3. Divide by the exponent, so I'm dividing by 3. And if I simplify this, the antiderivative is 1/3 x cubed plus c. Check your work. If you're checking your work and you're taking the derivative of this, you do end up with x squared. Find the antiderivative of 5x squared minus 3x plus 7. So again, I'm going to add 1 to the exponent and divide the coefficient by the new exponent. So add 1 to the exponent, so I get x cubed. Divide by the 3 to the coefficient, so I have 5/3 out front. In the second term, I add 1 to the exponent, so add 1 makes x squared. Divide by the exponent, so -3 gets divided by 2. 7 becomes 7x, and I have to remember to put the plus c at the end because you're adding a constant. If you check your work and you take the derivative of this, you end up with the question. Now here's some popular antiderivatives, and they are on a formula sheet that I give my students, so hopefully your teacher will give you the formulas. So you don't have to memorize these, you just have to be able to use them. And I'm going to do a couple of questions using these popular antiderivatives. So for the next example, it says find the derivative or the antiderivative of 2 cosine x plus 4 sine x. We know that the derivative of cosine is sine, and we know that the derivative of sine is negative cosine. So the antiderivative becomes 2 sine x minus 4 cosine x plus c, the constant. And that's it. You just have to go in the reverse. The derivative of cosine backwards is sine, and the antiderivative of sine was negative cosine x. So you apply that to the question. The last example that I have for you is to find the antiderivative of y equals x plus e to the 5x. And if I'm taking the antiderivative of x, x has the exponent 1, so I add 1 to the exponent, which would make it a 2, so I divide by 2. So x becomes 1/2 x squared. And if I take a look at e to the 5x, and I look at my popular antiderivatives in the formula sheet, the 5 becomes the fraction out front. So you can see that I have the formula there. E to the kx is 1 over k e to the kx. So I've completed my antiderivative for x is 1/2 x squared. The antiderivative of e to the 5x, by following the formula, I get 1/5 e to the 5x plus c, which is the constant at the end.